Going. Okay, this is the second assignment for Chapter 10. Hopefully everyone in here will stop talking about Pokemon cards so we can actually do the problems. 9. Paying for college. Yeah, that's going to happen soon. College. Financial aid offices expect students to use summer earnings to help pay for college. But how large are these earnings? One large university studied this question by asking a random sample of 1,296 students who had summer jobs how much they earned. Financial aid office separated the responses into 2 groups based on gender. Here are the data. Wow, how nice. They put everything listed for you. You don't have to try to read the problem, really. You can just look right there. It says, how can you tell from the summary statistics that the distribution of earnings in each group is strongly skewed to the right? Colin, you asked me this one earlier today, didn't you?
Mm-hmm. Well,
and I think we decided...
Right, because the X-bar for males is so much higher than the X-bar for females, you can tell it's skewed.
Okay, that works. So, he said...
Ew, Colin.
39A. What did he do?
Doritos out of the trash.
I saw him banging Doritos. I was like, there's so left.
No, that's so gross.
Okay, we're wasting time. Sorry, guys. Jack, Colin just finished off your Doritos in the bag that you threw away, if you're listening. 39A. Here we go. So as Colin said, we can tell the data / differences are skewed since the male's average is so much higher than the females. And then, oops, it's supposed to tell me if I'm off the thing. There we go. And the use of 2 sample T procedures still justified. Why? Why, Arthur? Oh, I thought you were answering the question. Go for it.
Wait, so do I have to do shape, center, and spread or no? Can I just leave it out?
Use T procedures since each sample size is at least 30. And they were random, weren't they? Yep. And the groups were randomly chosen. Part B, construct and interpret a 90% confidence interval for the difference between the mean summer earnings of male and female students at this university. So if you haven't figured out yet, the state part for the intervals, it's really just nothing. We're just going to smash it into the plan at this point and say we want what do we want? 90% confidence interval. And they already told us, asked if we were using T procedures, so they told us that much. The information they gave us was on averages, and so it has to be a 2 sample T interval that we're going to do in the calculator. Yes, Arthur? Yeah.
I don't understand what 2 sample T interval is. I mean, when I went to the...
That's what we're doing right now.
I know, but I went to the glossary. It's like when the random 10% and normal large sample conditions are met. Approximate C% confidence interval for mean 1 minus mean 2 is, this big formula. Here T star is a critical value in which areas C% between negative T star and T star for the T distribution with degrees of freedom, either option 1 technology or option 2, smaller of N1 minus 1 and N2 minus 2.
Okay, Arthur, pause for a moment. We're going to multitask, and you're going to do number 39 with us. See you on number 39. Bye, Callie. Thanks for your help. Callie just filed papers. We have two different X bars. We have X bar male and X bars female. And they want us to do, an interval. What?
He wants to do weight.
They want us to do an interval. So we're going to look at these two values. And when I was describing the sampling distribution with you, what did we do with the two means? What did we do with the two means?
Subtract them.
Subtract them. That's what we're going to do now. The difference of these two.
Wait. If you're subtracting those two, then how come it's not two sample T interval for X bar 1 minus X bar 2 and sampling distribution of mu 1 minus mu 2?
It's not X bar 1, it's X bar male and X bar female. And I'm subtracting them. And we're going to look for the true difference of the means of the males and the females.
So, in a sentence, how would you phrase what the two sample T interval is?
When you take two mean differences, the difference of two means, I guess, and you make an interval based off of their difference. To try and get the true mean difference of those two samples, the proportions, populations, I mean. I'm just throwing out words now. Arthur, that is fully explained on the YouTube video. I'm trying to make another video right now. Pull out a laptop. Look at the YouTube video. Two sample T interval, or do this problem with me right now. How organized my board is. Where's the doing? Sorry. Alright, here we go. We got that plan. Two sample T interval for reading the problem. Mean difference between the mean, I think I wrote mean in there twice, I didn't need to, the mean summer earnings of male and female students.
So you take two mean differences, you make an interval based off of their differences, and then to try to determine.
I'm going to finish this problem, Arthur. You can follow with me or not. Conditions were already met in part A. So, now I'm going to go to the do part and look for my two sample T interval. So I'm going to hit stat, go over to test, two sample T int, and I have statistics, and they gave me all my information, so I'm going to type it in. Standard deviation was large. And the second one Sea level is 0.90. Pool, no, stay out of the pool. Pooled is when you assume they come from the same population, and we can't do that. That's why we're using a t-distribution. So we calculate, and we get that the difference between my two numbers up here, Arthur, listen to this. If we were to subtract these two numbers, I'd get the number that's directly in between this interval. The number that's directly in the middle of this interval. And then I calculated the standard error. The calculator did that for me. And I added so many standard errors in one direction and so many standard errors in the other direction.
So what are you trying to determine with
The interval. We're trying to estimate what the true mean difference is. And that true mean difference of the populations could be anywhere from 413.62 to 634.64. Now notice on this one that gives you the degrees of freedom. The degrees of freedom is a very long formula that you will never have to calculate by hand. If you're curious, I could look it up for you at one point. It used to be in our old textbook. It's not in this one, I don't think.
Yeah, it is.
Oh, it is? Okay.
X bar 1 minus X bar 2 in parentheses plus or minus T star times the square root.
No. I said for the degrees of freedom, Arthur.
Oh. I thought you were talking about, you were on T interval.
Mm-hmm.
I thought that you were on two sample T intervals. So they're different.
And the degrees of freedom is different for one sample than it is for two samples. So since the degrees of freedom is so large, you could basically use your z-star for 90% confidence interval because it's so big. So z-star is 1.645. If you really want to make sure that you get the correct t-star in there, we could go to second vars and do 2 CDF. And I'm thinking of the tail probability. I want something really, really small, so I'm just going to put like -10. For 90% confidence interval, the tail is 0.05. And then I'm going to put in the degrees of freedom. That didn't work right. Okay, scratch that. I gotta think about what just happened. But we're gonna use the z-star 1.645. We look at the table. The t-star for the degrees of freedom, it only goes up to 1,000. So this is 1.96. Oh, I wanted to do inverse t. That's what I wanted to do. For 90, it's 1.645. Let me try that again. I wanted inverse t. That's night school, Arthur. Stay up. Inverse t. Tail probability. 0.05, comma. 1249.213. And it's basically giving me 1.645. That's how we get t-star. Alright. So you could write it as t-star or z-star if you feel safer, which I think maybe we should just keep it as t. Alright, so next problem, plan conclude. $656. $39. For C, it says interpret the confidence level in context of this study. So we're not done yet. Conclusion, we're going to say we are 90% confident at the difference, and I'm just rewriting what I've written up above, the difference between mean summer earnings of male and female students falls between for 13.62 and 634.64. Since that interval does not contain 0, if we were doing a test, we would say that we would reject the null because they're supposed to be the same in the HO. Part C wants us to explain what confidence means. So in several random samples, %90 of the confidence intervals of the same sizes as above would contain the true difference between the mean summer earning of male and female students. That wraps up 39. 43. I did this one in class today in first period B day. 43. We'll do it again. 43 wants to know who talks more, men or women. So, researchers equipped random samples of 56 male and 56 female students from a large university with a small device that secretly records sound for a random 30 seconds during each 12.5-minute period over 2 days. Then they counted the number of words spoken by each subject during each recording period, and from this estimated how many words per day each subject speaks. The female estimates had a mean of 16,177 words per day, the standard deviation of 7,520 words per day. For the male estimates, the mean was 16,569, and the standard deviation was 9,108. Do these data provide convincing evidence of a difference in the average number of words spoken in a day by male and female students at the university? So, they want evidence, convincing evidence, and we're going to look at that last line because that's going to help us when we write certain things like the conclusion. And since they want evidence, that means we need a test. And if you're following along, they gave us a mean. And we have 2 different groups, male and female. So that means we have a 2-sample t-test. So we want evidence. So on the top of your paper, for 43, remind yourself the whole time you're doing a 2-sample t-test. So your state, I'm going to write the HO, and you have the mean of the males should equal the mean of the females. The was asking if there was a difference between the two. They wanted a difference, so not equal to the mean of the females. And then the plan, we have 2 random samples. One of, how many were there? 56 males. And one of 56 females. Both are larger than 30. So it's okay to use t-distribution or t-procedures. And we're going to do 2 sample t-tests like we said earlier. So I'm going to go to the calculator and get all my numbers and then copy them down. So I'm hitting stat, over to test, 2 sample t-test. I have statistics. And I have to read through this problem. 16177. This is sample mean. The standard deviation was 7,520. Sample size was 56. And then for the second one, it was 1,659, or 16569. 9108. Again, it was 56. We wanted a mean difference. Stay out of that pool and calculate. So there's our t-score, and our p-value is huge. Degrees of freedom, and all our other information I'm going to copy down. So I have that t equals negative 0.248, p-value is 0.804, degrees of freedom 106.195, and x bar 1 is 1016177, x bar 2, oops, we should write male and female here, x bar male, x bar female is 16569, and then standard deviation of the male 7520, standard deviation of the female 9,108, and then we had sample size of 56 for each. I don't need to really write that down.
Isn't it the other way around? The males ended up talking more, but had a higher standard deviation.
Did I copy him down wrong? Oh, you're right, I did. Thanks, Tony. Is that whiteout? Trusty whiteout. So these were females were first, and then males. Thanks, Tony. And then conclusion with a p-value equal to 0.804. That's not lower than alpha equal to 0.05. We do not reject HO. we do not have evidence that, I'm going to go back to the problem and rewrite what they said. 43 of a, that there is a difference in the average number of words spoken in a day by male and female students. At this university. And then, hello, we have 57 through 60. 57. Ooh, these are the fun ones. There are two common methods for measuring the concentration of a pollutant in fish tissue. Do the two methods differ on average? You apply both methods to each fish in a random sample of 18 carp. Well, if there's two common methods, you apply both methods to each fish. So the same fish is getting both methods. That's going to be your paired t-test. So 57 should be A. Now we haven't practiced a lot of paired stuff. We'll do that after break. But yeah, this one would definitely be a paired because you're doing the same thing to each fish twice. So 57 should be A. And then 58. We have which of the following describes a type 2 error in the context of the study? Oh, we have to read the problem. Study of road rage asked random samples of 596 men and 523 women about their behavior while driving. Based on their answers, each person was assigned a road rage score on a scale of 0 to 20. The participants were chosen by random digit dialing of phone numbers. The researchers performed a test of the following hypotheses: that the average for males on their road rage score was equal to the average of the female road rage score, and that there was a difference between the two. So this one's asking which of the type is a type 2 error. Type 2 error, you don't reject your hoe even though you should. So this is what we're thinking is true, that there's no difference, but there actually is a difference between the two. So A says finding convincing evidence that the true means are different. Nope, because we're supposed to fail to reject HO. Finding convincing evidence that true means are different. Nope, because we're supposed to fail to reject our HO. Not finding convincing evidence, not finding convincing evidence, not finding convincing evidence. So it's between C, D, and E. So I'm going to compare what they say. That the true means are different for males and females, when in reality, the true means are the same. Sounds pretty good. What's the next one say? Not finding convincing evidence that true means are different for males and females, when in reality they are different. Nope. That doesn't make sense. That would mean that you were right and you didn't make an error. E, not finding convincing evidence that the true means are different for males and females, when in reality there is convincing evidence. No. Nope, that whole is convincing evidence. Nope. Because it's like somebody in the population comes back and proves you wrong and says this is the actual values you should have had. Like your data was wrong or something. So the true means are different. Nope. So it should be C. So 58, C. 59. 59, I have the p-value for the stated hypothesis is 0.002. Interpret this value in the context of the study. Okay, remember the p-value says if null is true, it's the probability of getting your sample results. So A says assuming that the true mean road rage score is the same for males and females, all right, assuming the null is true, there is a 0.002 probability of getting a difference in sample means. No, that's saying the ha, and I want my actual sample results. So assuming that the true mean road rage score is the same for males and females, there's a 0.002 probability of getting an observed difference, at least as extreme as the observed difference. That sounds pretty good. What's C say? Assuming that the true mean road rage score is different for males and females, there's a 0.002 probability of getting an observed difference, at least as extreme as the observed difference. That is saying assuming that they are different when they're not. So B is better than C because C is saying assuming the ha is true, which is not our case. And then D, assuming that the true mean road rage score is the same for males and females, there's a 0.002 probability that the null is true? No. It's the probability of getting our sample. And E, assuming that the true mean road rage score is the same for males and females, there's a 0.002 probability that the alternative is true. Nope. We don't have any probability for those ho or ha being true. So it should be back to B, 59. B. And then we have 60. 60 says, based on the p-value in exercise 59, that was the 0.002, which of the following must be true? A 90% confidence interval will contain 0, a 95, a 99, a 99.9. That p-value was really, really small. It was 0.002. And this one says it's impossible to determine whether any of these statements is true based only on the p-value. No, it's not impossible to know. We just have to think about our confidence intervals. And so for this one, for a 90% confidence interval, if we're saying that it contains 0, that means that you fail to reject when your interval contains 0 in this case. So if your CI contains 0, that would imply that you fail to reject HO. Well, your p-value is 0.002, so you have to come up with an alpha level that would fail to reject that. The p-value, however, is doubled because of the not equal to. For the ha, we had not equal to. So that means on one side, our p-value is half of that 0.002. So on this side, it's 0.001, and on this side, it's 0.001. So how much is on the middle? If it's 0.001 on each side, so if I do 100 minus, on my calculator, minus 0.002 divided by, nope, or just minus 0.002, I end up with 99.998 as my confidence interval. And 60 had a 99.9% confidence interval, would contain 0. So I'm thinking it was that one. 99.9% confidence interval will contain 0. course, I'm also getting tired and turned around right now. Number 60, don't worry, I didn't put one this crazy on your test. The ones I used were more obvious. This is really higher level thinking right now. Oh, where's 60? 10.49. These are the review. 10.60 should be D. Yep, they said it was D, which is confusing me because it's a 99.9% confidence interval. Would contain 0. I don't know, gotta think on that one. It's not clicking for me. Alright, I'm gonna go ahead and hit 61 and 62 just because it's on the same page and I'm right there. It's page 660. Got 61 and 62. And they just want you to figure out the test based on the situation. So 61, which inference method? This is a good practice for those of you that were getting confused. So 61, drowning in bathtubs is a major cause of death in children less than 5 years old. A random sample of parents was asked many questions related to bathtub safety. Overall, 85% of the sample. So we've got a percentage. That's proportions. Right now we only have one group, so it's a 1 prop. And then they said estimate the percent of all parents of young. Estimate means confidence interval. So number 61A should be a 1 prop Z interval. B says, how seriously do people view speeding in comparison with other annoying behaviors? A large random sample of adults was asked to rate a number of behaviors on a scale of 1, no problem at all, to 5, very severe. Do speeding drivers get a higher average? Ding, ding, ding. Average. So that means it's means. So it's T. Do speeding drivers get a higher rating than noisy neighbors? So it kind of looks like we have 2 different groups going on. What's the matter, Colin? How seriously do people view speeding in comparison with annoying behaviors? Large random sample of adults were asked to rate a number of behaviors on a scale of 1, no problem at all, to very severe. So we have speeding drivers and noisy neighbors. I'm going to look at that as 2 groups. So I'm going to say it's 2 sample t-test. Even though it's not really clear on whether they want the test or not. Going with 2 sample t-test. For means. Yes, Arthur.
I just watched the video and the 2 sample t-test is not defined. You just say what the shape, center, and spread of it are and how to do it in your calculator. You don't say what it actually is.
We have a sample, 2 samples, that we found the difference of their means. Just listen. We found the difference of their means. And we're trying to see if that difference is far enough away from 0 to be considered extreme. (61C). You have data from interviews with a random sample of students who failed to graduate from a particular college in 7 years. And also from a random sample of students who entered at the same time and did graduate. So we have 2 groups. You will use these data to compare the percents is proportions, of students from rural backgrounds among dropouts and graduates. It doesn't really say, again, if you want a test or an interval, so I think either one would work in this answer. I'm going to stick with the test though and say it's 2 prop z-test because we have the percents and we have two groups.
Two mean samples.
Yep.
Two
And you
mean-
find their difference
Find the difference of two means.
and see if that difference value is far enough away from 0. So D, do experienced computer game players earn higher scores when they play with someone present to cheer them on or when they play alone? 50 teenagers with experience playing a particular computer game have volunteered for a study. We randomly assigned 25 of them to play the game alone and the other 25 to play the game with a supporter present. Each player's score is recorded. Since we're looking at scores, it has to be an average, and we have two groups. We're not looking at the proportion that played or didn't play, or won or didn't play. We're looking at their scores, so that's averages. So I would go with a 2-sample t-test. And again, it could probably be a t-interval. 62. Same thing. How do young adults look back on adolescent romance? Oh boy. I was just checking answers real quick. How do young adults look back on adolescent romance? Investigators interviewed 40 couples in their mid-20s. Female and male partner were interviewed separately. Each was asked about his or her current relationship and also about a romantic relationship that lasted at least 2 months when they were 15 or 16. One response variable was a measure on a numerical scale of how the attractiveness of the adolescent partner mattered. You want to find out how much men and women differ on this measure. Well, since they're doing scale, and you've got numbers on that scale, we're trying to see if they're different. It doesn't sound like it's proportions. And you're asking the same people to compare now, current relationship, and that same person is being asked when they were 15 or 16. When the same person gets asked two different things, that's a match pair situation. So this would be for A, match pair. T-test. And then B, are more than 75% of Toyota owners, okay, stop right there. That's a proportion because 75%, let's design a random sample. We got a random sample of 400. There was just one group, so it's a one prop Z interval or Z test. Did they say they want an estimate? I don't know. It could go interval or test, in my opinion. One proportion Z. Let's go with interval because it doesn't sound like you're comparing it to anything other than the 75%. C. What'd the book say? They said test. So let's scratch and put test. C. We have are male college students more likely to bench strength than female college students. The Harvard School of Public Health surveys random samples of male and female undergraduates at four-year colleges and universities about whether they have engaged in binge drinking. So that's a yes or no answer. So that means it's categorical. We have proportions. And we have a group of males and we have a group of females. So we're looking for the test, 2 prop Z test, basically, between males and females. And then D, the bank wants to know which of the 2 incentive plans will most increase the use of its credit cards and by how much. How much sounds like a mean to me. It offers each incentive to group of current credit card customers determine a random and compares the amount charged. So that's an amount that you can find an average for during the following 6 months. So we have 2 incentive plans. It offers each incentive to a group of current credit card customers and compares the amount charged during the following months. It still sounds like you're going to have 2 groups, because customers are either going to pick the first incentive plan or the second. They're not comparing the person picking each one and how much they spend. So I would say it's a 2 sample T, and it could probably go interval. It wants to know, and we don't have the actual amount, which in 2 incentives will most increase. So I would say 2 sample T interval. If you want to do a test, that would work too, I'm sure. Just see which one, remember which one you subtract from, or if you want to do the test, sorry. Okay, so that wraps up page 660. Got one more assignment to go.